Hi, welcome to another video on my channel, and if you're new to the channel, please subscribe to the channel so that you can be notified whenever I upload new content, new videos and new information, right? Lots of information and solutions from different topics that I am working on to upload for you. So if you're new, please subscribe and get comfortable with exploring and navigating through my channel, through my different playlists, different videos, etc. And if you are a returning viewer, I want to thank you for coming back to the channel to view the content that is here. And if in any shape or form these videos are creating value to you, if they are helping you to become better at mathematics, I would want you to show your appreciation by commenting anything relating to the videos that I do, and also share the videos and the channel link to families and friends so that everyone can benefit. So for this video, I'll be looking at index numbers and doing quite a few things with index numbers. So what we'll look at for this video is basically to define index numbers. What is an index number? For objective 2, we're going to learn how to expand index numbers, and for objective 3, we're going to calculate numerical values for index numbers. So quite a handful of things here, but once you put your mind to it, it will increase your mathematical IQ. Now let's move straight into this. Alright, so an index number is a number which is raised to a power, right? And the form that you see here, I use A because A can represent any number, right? A can be any number. So I didn't write something like 2 to the n, because if I had written 2 to the n, then this would seem as if it only applies to the number 2, right? So I use letter instead. So A can be any number, right? Right, so I actually chose that. So this is the form of an index number, where A is called a base. I'm gonna go through this with more detailed explanation. A is called a base, and n is called the power index and also the exponent, right? So the power is also known as the index. Well, the power, also known as the index, tells you how many times you have to multiply the number by itself, right? So the power tells you how many times you need to multiply the base by itself. For example, 2 to the 5th power. You read it as 2 to the 5th power, or 2 raised to the 5th power, right? This basically means you have to multiply 2 by itself 5 times. So this 5 at the top tells you how many times you should multiply it by itself. So in this case now, we have the solution here, 2 to the 5th. So 2, which is the base, is what you're going to repeat. So you're going to repeat the base, and the 5 at the top tells you how many times. 1, 2, 3, 4, 5, right? And then you can write your answer here. We're gonna go through each of these stages, because these are three different forms here. So we're gonna go through each of those so that you can understand this better. Alright, so parts of an index number. And as I said before, I chose A to the n, where I had explained that A is the base, right? So that's the big number at the bottom, and n is the exponent or index or power, just like what I explained earlier, right? So this is for the left column. Now if you should look to the right, where I chose a specific example, As in, so this would read 5 raised to the second power, or 5 squared, right? 5 squared. So in this case, 5 would be our base, right? And then 2 would be our index or power, are also the exponent, right? And again, the big number 5 is called the base and is what we multiply together, right? So in this case where we have 5 to the second power, or 5 squared, the base is what we repeat, 5, 5. And the index, the power, or the exponent tells us how many times. So in this case where we have 5 to the second power, or 5 squared, we multiply 5 by itself 2 times, right? Multiply 2 of them because we have 2 at the top here. And this would equal to 25. But as I said, we're going to explore all of those. Right, so let's go through the different stages that we can write index numbers. So we have the index, expanded, and the number form, right? So as I explained earlier, let's use we're using about the same example, 5 squared. So as it is here, 5 squared, this is in the index form, right? Anything that is in this form, a to the n, as in 5 squared, is called the index form. So just as though it is base and exponent, index form. So 5 square, or 3 square, or 5 cube, or 5 to the third power, all of these are in index form because they have a base and an index at the top, or a power, or an exponent. So we have this. So 5 times 5, which would be this stage. This stage is known as the expanded form, right? Expanded form, because we expand it. And when you expand something, you make it a bit bigger, right? So if you notice the size of this compared to this. So we expand it, so we open it up, or we make it bigger. So this is called the expanded form. And when you move to the third stage now, take this, when you move to the third stage, which is 25, you got this by multiplying 5 times 5. So you multiply the index, the expanded form, to get this form, which is known as the numerical form. So sometimes a teacher would ask specifically for the expanded form or the numerical form. So it's important for you to know which form you should stop at, because sometimes whenever I ask for the expanded form, some students tend to calculate everything and give me the numerical form, right? So it's important that you know the difference between all of them. So we expand the index form to get the expanded form, and then we multiply the expanded form to get the numerical form, right? So feel free to pause the video, go through that, or view it again. Alright, expanding index numbers. So as I said, all these numbers all numbers in this form. So for number 1 you have 2 cube, or 2 to the third power. Number 2 we have 4 square, 3 negative 2 to the fourth power, 5 negative 4 negative 3 to the fifth power, 5 10 to the sixth power, and 6 7 to the first power. So all these are in expanded form because we have a and we have a n, base and exponent. So once you see the word expand, you know that this is what we're going to do. This form, we're just going to expand it using the multiplication sign. So if I should move over here now, expand the following index numbers, right? This would be equal to, so we have a base of 2. So the 2 is what you're going to repeat in terms of multiplication. We have a base of 2 and we have a power, our index of 3. So this means you multiply 2 by itself 3 times. So 1, 2, 3. right? So these 2's came from the fact that we had a base of 2, and the how many times we multiply 2 came from the fact that we have 3 at the top. So 1, 2, 3, right? I hope you're getting this now, you know. So let's move on to number 2. 4 square, or 4 raised to the second power, right? In this case, the 4 is what you're going to repeat. So we have 4. How many times do we multiply 4? 2 times, because we have a 2 at the top. 4 multiplied by 4. This is not 4 times 2. That's not it, right? So that's saying 4 multiplied by 4. Move to this one now. Alright, I forgot to put a bracket right here. Let's put a bracket here. So we have a base of -2. Yeah man, we can have negative numbers. -2. So -2 is what you're going to repeat. -2 times -2. How many times are we going to do that? 4 times, because we have a 4 at the top as the power. Times -2 times -2. So we did that 4 times. 1, 2, 3, 4. Why did we do it 4 times? We have a 4 at the top as the power. So I hope you're getting the swing of this now. Moving forward. So we now have -3 to the 5th. Alright, and this is kind of a special case now when it comes down to a negative base. For the first one, you had a -2, and we repeated the -2, the -2's. But if you notice, the -2 was in brackets, so this was treated as 1. The negative on the 2 was treated as a single unit. And the exponent has effect on what is immediately to the left of it. So in this case, since -2 is in bracket, we treat it as 1 unit, so we actually repeat the -2's. But if you notice, for number 4, if you notice the 3 is what is immediately to the left of 5, right? We have a negative now, but it's far away from the exponent than 3. And remember, the exponent takes effect on what is immediately to the left of it. If we had this in bracket, then we could have treated it like this. So in this case, we won't apply the exponent to the negative. So we put the negative right there, and we apply the exponent to what is immediately to the left, which is the 3. So 3, how many times we do this? We do it 5 times. 3 times 3 times 3 times 3 times 3. So this is basically the expanded form for this. And for number 5, trust me, this works the same with every number. 10, so 10 is our base, so this is 10 raised to the 6th power. 10 is our base, so 10 is what we're going to repeat. How many times? 6 times. So that's 10 times 10 times 10 times 10 times 10. Let me see how much that. 1, 2, 3, 4, 5. One more. Times 10. You see that? Very easy. In this case now, we have 7 raised to the 1st power. So 7 is what you're going to write down as your number. 7. How many times do we write 7? For this part where we had the 3 at the top, we write 2 3 times. We had 2, so we write 4 2 times. We had 4, so we write this 4 times, etc. So any number you have at the top, that is the amount of time you're going to write the big number. So 7 to the 1st power is just 7. Because we have a 1 right here, so we just have 1 7 right down there. So, and that's basically how we carry out the expanded form of exponent. So feel free to go back to the examples, rewind, watch over to get the concept, because these are important concepts to give you a solid foundation. So we'll continue in another video on how to find the numerical values of expanded numbers. Thanks for watching.